Hi everyone, I'm Ankit Mathur and I'm a lead for the file protocols for FlashBlade and I work out of the Biostorage office at Bangalore. So this is one of our inaugural series of the Pure Dialogue where we are planning to have an engineer to engineer communication and talk for a broader engineering community. So today I have a very special guest. I have been with the storage industry for nearly 20 years, but this person has been here longer. My guest for today is none other than John Coz Colgrove. He is the founder for Pure Storage. He founded it in 2009, and before that, he has been a founding engineer at Veritas. He has 450 patents to his name. Coz, that's awesome.
Thanks a lot for having me.
So, Coz, you have been with the industry for around 40 years and have seen the storage industry change, the innovations that have happened in the storage world. So, my question is from people who are at the verge of making a choice, who are coming in from college and want to decide whether they should switch to a storage industry background or to something else. What advice do you have for them? Like, what innovations are still to happen in the storage world?
One of the things that storage, it's the lifeblood of organizations, right? The storage is the history. And you think about like our whole culture, it's all around understanding our history. Storage is a key vital component of that. Now, AI, which everybody's interested in, AI is all about analyzing your data, understanding your data, using that to then create a model by which you can go forward into the future. Right now, AI is focused a lot on training use cases, where people are using a lot of GPUs and data to train models and build so they can do much better predictions. But AI is going to cause an explosion in storage when it starts being deployed everywhere, when it starts being used in everything each business does. Then the business will see the way they use the data will grow. They'll need much more performance from their data. They'll need much more accessibility to it. I'm not going to do something like, oh, I'm swiping my credit card. They want to do fraud detection right away. They're not going to be offloading it to some different storage system. It's going to be built into the storage system they have, the data processing system they have. So really, I think the future of AI is all about what the storage can deliver for it. And there's going to be also a big explosion because AI means that all data has value. So today, companies gather all sorts of data, governments gather all sorts of data, a lot of which they view as not really that useful. I have security camera footage from thousands of cameras around the city. The AI sort of can scan the images and can gain valuable insights from it. AI is going to drive much greater retention of data and thus, again, much larger demands on storage. It's going to be really exciting to see what happens because I fully believe that over the next 20 years, AI will be as profound a revolution for all of society, not just for those of us in tech, as the internet and the smartphone was in transforming society 20 years ago.
So on that cause, I have a follow-up question. So the era of when you had only 16 KB of RAM and you had like little CPU, you would optimize every last kilobyte. You would fight for it and you would have to work it through. But now, today, people actually have much more RAM at their disposal, much more CPU. So the run-of-the-mill CPU and RAM that you have, people focus more on the algorithm, but the hardware is anything is good enough. So for the storage as well, do you see that off-the-shelf storage now is good enough and people really don't need to optimize it as much? Like, what should people who are coming into the industry do? Really, are there any good problems that you would advise to people coming out of college or coming into the storage industry?
I've personally always found some of the problems of optimization and scale to be very fun ones to solve. They're challenging around thinking of different algorithms, different ways of approaching the problem. So that's something that I've always enjoyed. We have more available now, but we also have more demand. And I remember back when I was working at Bell Labs, I went to an internal seminar once And they started the seminar by saying, okay, everybody go around the room and talk a little about what you're working on. And there was a fellow in the room who was talking about working on these massive phone switches that would control the phone systems for entire cities. And he was talking about all the features they were trying to add and how much trouble they had squeezing all of them into the memory they had available, which was only 4 MB, right? And then, like, the very next person to speak worked on satellites. And he's like, we have to fit everything in 4 KB. I'd love to have 4 MB. So it's all a matter of perspective. I see people today trying to deploy giant clusters of GPUs and fighting for every cycle of those GPUs because they spent so much money on it. I see people who are trying to store data and they buy giant storage systems and just still do not have enough data or enough space available for all the data they have. Then meanwhile, you start deploying storage systems. We're talking today about having hundreds of terabytes in a device and heading towards petabytes, and thus having, tens or hundreds of petabytes in a single storage system. And hyperscalers are doing tens of exabytes in a single system. So there's huge problems still in how you optimize this, how you deal with it all efficiently, how you make it all work. Because what's more important than ever is it's got to work all the time. 20 years ago or 40 years ago, so many fewer things were dependent on. Now, it's like everybody's dependent on like their phone being available all the time. And then using the phone, accessing things. It's like their banking information, navigation, coordination, communications. My calendar's on my phone. Everything's on my phone. So it has to be available all the time. What we've done is we've shifted into a world where the tech availability is so much higher, the responsiveness is so much higher, and that means that the problems that you saw when you had much more limited amounts of memory, much more limited amounts of CPU, they're still all there. They're actually even worse, and you got to make it available all the time. That's what's exciting about it.
Speaking of which, now a lot of customers who want to try exciting storage, they buy smaller boxes. They have all of these cases, like you talked about the satellite guy and the guy who is managing phones and stuff. So everyone, the startups, they would want to start small. They have different use cases. They would put in storage for one thing of one kind, and then another storage for another thing, another kind. But then each application has different needs. So which means things are getting siloed and every storage looks different. I have heard customers say that they love their first storage experience. They love their second box too. But as it's growing, as the storage is expanding, they stop loving it. What do you think about it?
A couple of things with that. So first, when you're starting small, it's not worth optimizing it, right? Just, you're a small startup, you should be storing your first data in the cloud. Just use the cloud, it's right there. When you start growing, then you might start saying, okay, I should do something special for this use case or that use case. I think that's the first thing. Standardization is the key to simplicity. It's something that at Pure, we've always tried to build into our products, make them really simple and easy to use. And, it's simple to have one, it's simple to have two, but when I have 100 of them, who wants to do the same thing 100 times? That's one of the reasons why we're trying to do, this enterprise data cloud at Pure. The idea being, let's have one way in which you plan out your storage. You plan your entire infrastructure, you define a few simple storage classes, and then let the implementation of that happen, by the arrays intelligently as you allocate it. So I don't have to go and manage my storage array by array by array. Instead, I just manage my storage service. It's a much simpler way to handle a bunch of things. And that gets over the problem of, as I get a number of simple things to use, I'm doing repetitive tasks. The worst thing in any IT department is repetitive tasks. Humans don't like being repetitive, so they get slack, they lose concentration, they take shortcuts, and thus they make mistakes. It's something that is a challenge to every engineer at Pure, for example. We want to build a product that's really simple and easy to use, So as you add features and do anything to the product, you need to figure out, how do I do it so it's invisible, so it's intuitive, so it just works. Think about the products you use in your personal life. When you get a product that really, it's simple and easy, and when you try to do something with it, it just does what you want. That's the ideal product. And you say, I'm going to buy more of that. When you have a product that's a challenge every time you go to do something that's complex, that annoys you, you try to buy less from that. Being simple, being easy, but being uniform across your entire service, that is the key.
At Pure Storage, you have multiple storage products. So how do you ensure that customers who have gotten used to using one of them, they have the same simple experience all the way across?
So we have our flash array, our flash blade, we have Portworx, we deliver that as a service with Evergreen One. With all of those things, you want to have a consistent DNA in the product that helps it have similar use cases. So for example, I do something like support two-factor authentication. Well, should I say that one product picks one second factor and another one picks another one? I remember the days when every bank that I dealt with gave me my own dongle to carry around that had my 6-digit code. Now it's just, I have an app on my phone, and whenever I want to do the two-factor, I either get a text to my phone or I go to the authenticator app on my phone and I pick the number out of it. And that helps unify everything, so I have one way to do it. It means, by the way, I'm also better at how I do that one way. Imagine if as you walked around your house, every time you walked into a room, the light switches were different. You'd sit there all the time like, oh, how do I do this light switch? How do I do that one? How do I get it right? They're all the same for a reason. And, that's the same kind of thing you need across all of the products in your portfolio if you want that simplicity. Now, sometimes products do different things and they have to have slight differences, but the look and feel, the style should be the same. All the things that don't have a need to be different must be the same. And that's the way you keep that simplicity as you go across products.
I always thank myself and thank my fortune that whenever I travel from India to the US, the brake is still on the left of the accelerator.
That's something that, I remember the first time I drove a car in the UK. And of course, the steering wheel, you're sitting on the other side, and you're always, as you're going down the road, you're kind of like drifting to the other side of the lane because you're used to it one way. But your feet, the brake and the gas pedal and the clutch, if you have a stick shift. And the first one I drove was a stick shift, so the stick shift was in my wrong hand. The pedals are the same, which I found kind of interesting. I'm sure I would have botched driving a lot more if the pedals were not in the same spot.
Saying that and stick shift, let me switch gears. So going back in the history, Coz, you were originally a software guy at Veritas, I believe.
Yes, I've always been a software person. I'm a software person at Pure too.
But then you have like this whole organization which is doing flash-based optimizations and setting Flash, which was something like EEPROMs, right? Erasable, programmable, read-only memories, came in late 1970s or 80s. Hard is a bit longer. But then you took the step, a courageous step, I would say, in 2009 to say that I will not do any spinning disk and I will do all flash.
I've been around the storage industry for quite a while, and disk has been an amazing technology from sort of 1970-ish through 2000, early 2000s. It kept improving at an astounding rate. The very first gigabyte hard drive was introduced by IBM around when I started in the industry. The way the capacity increased, the way the performance improved, and the way the price dropped was just astounding year after year. And then it stopped getting better at as fast a rate, and it stopped getting faster. And so you could see that more and more applications needed more performance than the disk could deliver. I sort of looked around and realized that flash was going to be the replacement, and it was finally time. There were other technologies that had the promise to replace hard drives, but as an engineer, you love to think it's all about the tech, but really it's all about the money. Economics drives this. And so the disk kept getting so much better that none of the other technologies could catch up to it and get to be reasonably priced. And that meant they all just became obsolete, too expensive, and fell behind. And the disk just kept going because billions of dollars a year in R&D just kept it improving. But when it stopped expanding at the same rate, that opened the door. Now, flash had started to become popular in consumer devices. So think your iPods and then your smartphones. And, my car has tons of flash, and, my laptop and every device that has flash. And in those consumer devices, the flash was more expensive, but it gave you better battery life. And it meant when you dropped the device, you didn't lose your data, and things like that, like with the iPods. Where even people would wear them while jogging, and the bouncing, as they'd run, could cause the music to skip. So the flash was just better for that. And so flash got to an economic scale where it was improving at a far greater rate than the disk. And so when I started Pure, I was looking at that and saying, disk is slowing down its improvement rate. Flash is going to catch up. Consumer flash, driven by those devices, had gotten to where it was close enough to disk that if I could use some of the extra, trade off some of the extra I/O performance you get out of flash to use data reduction and bring the price closer together, then I'd be able to produce performance-oriented systems that were similar in cost. And that's what enabled customers to flip. And, at the time, I saw that the curves would continue, and eventually flash would replace all of the hard drives. There were a lot of people who were very skeptical of that at the time, and felt I was a little too, you could say that they thought I was nuts. But the reason I was so keen on all flash as well, when you mix flash and disk, you start spending all of your effort, all your intellectual property on how to move the data between the flash and the disk, which isn't really that useful a thing. That sort of technology, caching stuff has been around for decades, and there wasn't some new development. Instead, we focused on all flash. We focused on treating flash like flash and taking maximum use of it. And so everybody else is out there using flash pretending to be a disk, which makes the flash less good. It sacrifices some of its performance, some of its capabilities to do that pretend I'm a disk. We focused on all flash, and that gave us a big advantage. And now as the economics continues and, things continue, we clearly see the end to the era of disks coming, and we have a substantial edge over the competition because of that all flash approach. And, you talked about me as a software guy in the past tense. I still am, but I do believe that when you have software married properly with the hardware, it's not about inventing new hardware. It's about tying the software and the hardware together so they are so fit for each other. You get great advantages in performance, cost, scale, simplicity, reliability. The list goes on and on. And that's why Pure mixes the software and the hardware in that way. It just gets a better product.
Yeah, I will ask you to elaborate more on that. So the NVMe interface that came in, it was a good thing to happen with Pure Storage. But then it was a bold move. You ripped out the FTL, which was there with the flash that all the vendors, Toshibas and Samsungs of the world, they were putting in. You said, off with that, take the raw flash, and then do your own magic potion on top of it and give it together.
As a startup, we couldn't really afford to build our own hardware or take any approach. So we used off-the-shelf parts, and that included off-the-shelf SSDs. But we get an SSD and we decide we were going to use it, and I would carefully study. I'd run all sorts of I/O patterns against the SSD and carefully study how to get around its firmware. And what we were doing was we were trying to say, how can we do I/O to it so that all of the smart stuff that we didn't really want the SSD doing wouldn't activate. We didn't like the garbage collection. It would come in at the wrong time and cause performance problems. We didn't like the remapping. We didn't like the way when we'd write data here, it would decide to put it over there. And so in the early years, we shipped off the shelf SSDs, but we tried to get them to be very passive and work around their firmware. And then we got to a point where we, now we had been shipping product for a little bit. We sort of knew exactly the kind of system we wanted to build to get the best result out of the hardware-software interaction. And we started building that, and that included basically taking, instead of SSDs, flash chips, building effectively our own SSD. And yes, we ripped out all of the firmware that we didn't like. So all the garbage collection and remapping taken out of the SSD into our main controllers. It means we can debug things with that better. We can fix the bugs more dynamically. We can adapt the algorithms more dynamically. It makes the devices more reliable. Now, for example, I was just reviewing our data for the last 3 months. We've got 1 million flash modules out there. We got a large number of them that we're getting telemetry from. For the last 3 months, our failure rates are like about 1/12 what the annual failure rates of SSDs are. And that's more like 1/20 what the annual failure rates of hard drives are. And think of what an advantage that is when you have so many fewer failures in the field. It means fewer humans going into the data center and making mistakes on things, as well as less disruption on your systems. So it's just been a great result to get the maximum resiliency and maximum consistency out of the hardware. And that's why we do the direct flash modules. Better consistency, better resiliency, better reliability, better performance, and, lower cost, better efficiency. It's like great in all sorts of ways.
So, Coz, when we talk about flash, what comes to your mind? Higher capacity or higher performance?
Well, unfortunately, both come to my mind, and you can't get them necessarily both together. I've been in this industry a long time, and you are almost always trading off memory for CPU or IO for processing power. You very seldom get a win in all dimensions. The flash is way higher performance than disk, but when you just start talking all flash, when we double the size of a direct flash module, generally speaking, the performance ends up about the same, so the data gets colder. The very same thing that was happening to disks. It's just we have so much more performance available that hasn't really hit yet. We do have some customers and some applications that need super high performance. And for those, you already see a bifurcation between people using the largest, densest flash modules, which give them the best economics, power per watt, and the smaller, more performant per terabyte flash modules. That's a trade-off we're always going to have. There's no magic bullet that will allow me to build a super high performance at every single scale that grows with flash kind of device.
So I hear you say that the panacea for all types of storage needs does not exist, or the innovation is still continuing in that direction.
I don't think the panacea exists. You talked before about how Pure has flash array and flash blade as two different storage architectures. Well, flash array is a scale-up architecture oriented around the lowest latency. Flash blade is a scale-out architecture oriented towards the maximum scale and maximum throughput. And I can't do the same thing with one architecture. I need the two different architectures for that. Now, I don't need 7 architectures. But I need 2. I don't see a technology handy which is going to give us effectively infinitely scalable performance. Unfortunately, that doesn't exist. And so I'm always going to be trading off scale against performance, right? And remember, that doesn't mean my performance drops when it gets bigger. It means my performance stays closer to the same. So if I double the size, I'm not doubling the performance. Maybe I'm getting the same performance. Maybe I'm getting 1.1x, but that means my performance per terabyte is what changes.
Because in this particular industry where we have multiple vendors for storage, where do you see Pure Storage as a vendor? Where do you see Pure Storage headed?
Well, obviously, we're going to be the biggest and best storage vendor out there. We have the best products. We're growing in the industry. Direct flash is the right way to go. We're now talking to hyperscalers about replacing all their hard drives. 1,000 exabytes a year, that's a lot of flash. We're growing and we're heading to number one.
So what you said about hyperscalers is a whole talk in itself. So I guess we will have to arrange for another one of our seasons, another episode, and we'll talk more about the hyperscalers. Thank you, Coz, for your time and enlightening us from the history and where Pure is headed and the technology.
Thanks a lot for having me.